Hello guys, we will see a question, very beautiful question. So the question is, which is related to mechanical metallurgy. Two specimens, both with circular cross sections and made from the same copper alloy, okay, are tensile tested in the USA and Japan. Okay, so one is being tested in USA and another in Japan. Okay, the same material. The US specimen has a gauge length of 25 mm and a diameter of 5 mm, whereas the Japanese specimen has a gauge length of 50 mm and a diameter of 10 mm. Plastic deformation begins in the US specimen at a load of 5 kN uh, and after failure the gauge length is found to have increased by 15 mm. Okay, what will be the corresponding values for the Japanese specimen? Okay, so guys, we have two specimens. Okay, so this is the rough specimen I am drawing. So one is for USA and another is for Japan, right? I think USA it is smaller, so it will be here USA and Japan. For Japan, this gauge length is 50 mm, right? And this diameter it is 10 mm. Okay, for the Japan. And for USA, the gauge length is 25 mm and this gauge dia is 5 mm. 5 mm. So what is basically it is asking that these two specimens are tested at their respective locations, and after the failure, so in the case of USA the elongation it has been observed that it is 15 mm, right? That means this delta L. So corresponding what should be the delta L for this Japan specimen? Since both the material are same, that means the both will have same YS UTS. Okay, so both material will have the same YS UTS because this YS and UTS are the material property, right? Okay, so the first concept which will be applied here is that we know that the YS will be same, right? So YS gives is given by the force divided by the area, right? So we have been given that it is showing plastic deformation at a 5 kilonewton. So this YS we can assume here like 5 to 10 power 3 Newton divided by the area of the USA specimen, right? So USA specimen is this, which has got 5 mm dia, right? So it will be pi into the diameter of this is 5, right? So we'll take the radius, so 2.5 mm into 10 power minus 3 whole square. Okay, here pi r square, so this will give us the YS, and since the YS is same, so for this Japanese specimen also the YS it will be the same, right? Now to calculate the YS for that, because since the here the diameter is different, that means it will take some other load which we don't know, so we'll write it as F divided by the area, but we know the area, so pi into 5 into 10 power minus 3 to whole square. So these two will be equal, right? So that means F by pi 5 into 10 power minus 3 whole square is equal to 5 into 10 power minus 10 power 3 Newton by pi into 2.5 into 10 power minus 3 whole square. So this pi it will be cancelled, this 10 power minus 3 10 power, so 2.5, so here it will be F by 5 square 5 into 10 power 3 2.5 whole square. Okay, so this will be like 2 square. So F in the case of this Japan will be 4 times of this F in USA, right. So that means it will start plastic deformation at a force which is equal to the 4 times, because the dia is different. So that means the force application it will be different, right. So that's what we have got, that we need to apply 4 times the load for the plastic deformation to happen. So this is it, one part it is we have calculated. So what is the corresponding value? So this it will be 20 kilonewton, right. So it can be D or E, right. So next thing we will calculate. Now since again we will apply the concept that since these two materials are the same, so that means the elastic modulus will also be same, right. So elastic modulus will also be same. So elastic modulus will be same, that means when we have the tensile testing, so this is the portion of elastic modulus, right. So there will be two tests, so it will be similarly like this. So this tangent will be the same, right, in the both cases. So E in the first case USA, it will be sigma, right, sigma ys divided by the strain. So strain in the case of USA it will be this, we have been already given the total elongation is 15, right. So we can write here 15 divided by the initial length, that is 25. So this is the strain, and the same thing it will be sigma, that is the ys, right, divided by the strain which it will be over there, right. So the strain which will be over there, it will be so delta L by N naught. So what is the N naught over there? So it is 50, right. So now this sigma will be cancelled because both are equal. So it will be 25 by 15 is equal to 50 by delta L. So this implies 3, 5, right. So this 5 into 10. So this delta L is equal to 30. So the increase in length will be this 30 mm, right. So here there is one assumption that the material is failing near to its ys, okay. So the correct answer it will be here like this, okay. So this is one interesting question which I found, so that's why I thought that I should discuss it with you, okay. So thank you all.